Basic electrical engineering. In this subject, now we are dealing the insulating material chapter. In this, we are studied the different type of materials used in our electrical engineering. And what is the insulation material? What are the different type of insulating materials used in our different type of applications? And after that, we are studied the different properties of this insulating materials. The properties are mainly physical properties, electrical properties, thermal, chemical and mechanical properties. In our previous video lesson, we are studied the electrical properties. That is insulation resistance, dielectric strength, dielectric loss and power factor. Now we have to study about the chemical properties. Chemical properties are solubility, chemical resistance, weatherability, like that. Solubility. Solubility. In certain applications, insulation materials can be applied only after it is dissolved in some solvents. In such cases, the insulating material, appropriate solvent, the insulating material is soluble in water, then moisture in the atmosphere will always be able to remove the applied insulation and causes breakdown. So we have to take care of this solubility. Because of that, if it is solved in water, then the insulation will damage. If the rain or anything, any moisture is appeared, then it will break. This is called dielectric strength break. At that time the insulation will be damaged. So you have to check its solubility. In some solvents it is dissolved in that. Some materials are soluble in water. Next, chemical resistance. Presence of gases, water, acids, alkalis and salts affects different insulators differently. Chemically, a material is a better insulator if it is resist chemical action. Sometimes some acid rains are also occurs. If in that situation, if it is not chemical resistant insulating material, then the insulation may be damaged, right? Certain plastics are found approaching this condition. Consequently, their use is very much increase. Chemically, a material is a better insulator if it is chemical resistant action. Next, weatherability. Insulators come in contact with atmosphere both during manufacture or operation. Because of that, for example, if our overhead distribution transmission lines are all just in overhead systems, it is in freely in the atmosphere only. The contact of insulation with the atmosphere is often so complete that even the less chemical aggressive atmosphere can prove a threat of the smooth running. We have to check its weatherability also. Sometimes due to winter, the cold conditions, moisture will come, and sometimes in rain condition, and so many times the moisture takes place. We have to check its weatherability. That's why hygroscopic nature is important. What is this hygroscopicity? The property of insulating material by virtue of which it absorbs moisture. The insulating material should be non-hygroscopic. The absorption of moisture reduces the resistivity of the insulator material. If the resistance is decreased, then it allows the voltage to flow in that insulating material. This means what? The insulation material strength is down. Due to that, the dielectric losses are more. That's why we have to maintain its resistance constant. Due to this weatherability, all those conditions, if it absorbs any moisture, then the insulation material automatically loses its resistance. That's why our insulating material must be in non-hygroscopic in nature, and it must be chemically resistant to some gases and rain acids, some water liquids like that. Okay, this is about the weatherability and hygroscopic. After the chemical properties, what are the chemical properties we are observed? We are observed the chemical properties of solubility and chemical resistance and weatherability. Weatherability means it must be non-hygroscopic in nature. These are the chemical properties. Up to now we have studied about the electrical properties. Now we have studied about the chemical properties, and after that we have to see its physical properties or mechanical properties. What are these physical and mechanical properties? Let's see. The physical or mechanical properties are mechanical strength, porosity, matchability and moldability, density, brittleness. Here viscosity, porosity, solubility, moldability, density, moisture, absorption, surface tension, uniform, extra are the various mechanical properties of these insulating materials are there. Some of the mechanical properties are important to study. One of that is mechanical strength. Let's say this mechanical strength. The glass is very much good insulating material, but its mechanical strength is very less. That's why it is very brittle in nature, right? That's why we are unable to use that in that proper applications. Let's see. What is this mechanical strength? The insulation material should have high mechanical strength to bear the mechanical stresses and strains during operation. Temperature and humidity are the main factors. In summer, the atmosphere condition temperature is very hot. Due to this temperature, the insulation material resistance will be very high. And its mechanical strength will be low. Due to this hotness of this weather condition, some insulation materials are melt. And humidity, when this humidity all the things are appear due to bad weather conditions. So temperature and humidity are the main functions which reduces the mechanical strength of this insulation material. Next, porosity. A material have very small holes in it. It is called a porous material. Okay, every material, it is having some small holes. Insulation material absorbs moisture if it is porous, which reduces resistivity as well as mechanical strength. Porous materials are impregnated with varnishes or resins or some paints to fill their pores, which makes them non-porous. Then it will give better insulating property, right? So what is the point, important point here? To minimize this property of this porosing, we have to paint on that insulating material with some varnishes. Varnish means some paintings. Then the small gaps of that holes will be filled. If the holes are we are leave that holes as it is, then what happened? It absorbs a moisture from the atmosphere. Then if it absorbs the moisture, then what happened? It reduces its mechanical strength. The mechanical strength as well as insulation resistance also reduced. That's why to maintain this, we have to apply some resins or some paints or varnishes on the material for better insulating property, right? What is meant by this porosity? Porosity means every material having small holes in it. It is called porous material. Insulating material absorbs moisture if it is having small holes. To reduce this property, we have to apply some coatings or some paints on that of the top layer of that material. Then the porous means that holes will be filled with these varnishes. Then this situation is used to prevent the absorption of this moisture. Otherwise, if it absorbs the moisture, then the insulation resistance will be decreased, and at the same time, due to these holes, if it increases these gaps, then mechanical strength also decrease. That's why we have to take care of this porosity very much by applying this type of some coatings or varnishes or resins to fulfill their pores, right? And this is matchability and moldability. What is this? Molding means what? To getting the desired shape. This property of insulating material help us to give the desired shapes to the insulating material. If it is having this matchability and moldability capability, then only it will give our required and desired shapes. Otherwise, if it is stubborn, then we are unable to shape it according to our wish. We have to take off its flexibility. If it is flexible to mold for any shape, then only it gives our different types of shapes. Because of that, here the machine and its parts are having different types of shapes and structures. We have to provide insulation for those parts. That's why it must be some flexibility to doing that molding. This property is called matchability. It helps us to give the desired shapes to the insulating material. After that, density. The insulation material should have low density. Then only it reduces the weight of the equipment. Otherwise, the equipment weight will be more. The equipment weight will be more than, for example, in overhead systems transmission and distribution condition. If the weight of that equipment due to this insulation, if the weight is more, then what will happen? It is always hanging in air, right? If the weight is more, then the weight on the supporting structures will be more. Due to this, stresses and strains, all those things are coming into picture. As well as possible, we have to maintain less weight. That's why we have to maintain low density to reduce this weight of the equipment in which insulating material is being used. After that, brittleness. The insulation material should not be brittle. Brittle means glass is a very good insulating material, but it is very brittle in nature, right? So it has limited application. Why? Because of that, if this is brittle in nature, no? If it is fractured, then what happen? The breakages occurs in this mean gap. Leakage currents, all those things are formed. Then we are not do at our right application. We are not justify the thing what I have to do. Here what is our wish? We have to provide proper insulation to prevent the flow of current and to prevent the leakage current. If the brittle nature is there, if it is fractured, then in that mean gap, what will happen? The leakage currents, all those things are occurred. Then we are not given any shock proof. To maintain our safety, we have to definitely prevent these fractures. That's why our insulation material should be not in brittle in nature. If it is in brittle in nature, then insulation material may fracture easily due to stresses. These are the mechanical properties. What are the mechanical properties we are studied up to now? We are studied up to now viscosity, porosity, solubility, moldability, density, moisture, absorption, like that. In this, the important things are brittleness, density, matchability and moldability, porosity, mechanical strength. These are the mechanical properties. So up to now we are learned about the electrical properties, that is insulation resistance, dielectric strength, dielectric loss, power factor, like that. After that we are observed the chemical properties, that is solubility, chemical resistance, weatherability and hygroscopicity. After these chemical properties, we are moved to physical properties or mechanical properties. In these mechanical properties, we are observed mechanical strength, porosity, density, moldability and brittleness. So we are studied all these properties of our insulation material. What is the purpose for this? We have to dig a ocean. Like that, we are having so many types of insulation material. In this, we have to dig a particular material for a right application, to choose this, definitely we have to study all the properties of that particular material. Then only we have to pick a correct item for a correct application. That's why here we are studied all these type of properties. Let's see what are the factors affecting these insulating materials. Up to now we are studied about the properties, right? After that you have to consider its factors also. Because of that, depend upon these factors, the insulation resistances values may be changed. That's why you have to consider its factors also. The factors mainly we are observed are temperature, moisture, applied voltage, aging also. Let's see the temperature. With rise in temperature, the dielectric loss also increase. As the temperature of the insulation material falling, material rises its resistance. Moisture. In the presence of moisture in the insulation material, what happens? It increases the dielectric loss in the insulator. Why? Because of that, due to this moisture, insulation resistance will be reduced. If the material absorbs moisture, definitely insulation material value, resistance value will be decreased. So, the insulation material must be non-hygroscopic in nature. After that, applied voltage. Dielectric rises, dielectric loss rises means increases with increase in applied voltage. So, this dielectric loss is one of the factor in limiting this operating voltage. That's why in underground cable or overheaded system, whatever it may be the system, we have to classify it as low voltage cable, high voltage, extra high voltage, ultra high voltage, like that. Because of that, depend upon these voltage values, we have to provide its insulation. For example, in underground cable, we are used this operating voltage up to 100 kV only. Because of that, in this underground cable, all the cables are insulate with proper insulation material. That insulation material bearing strength is up to 100 kV only. That's why this application is limited up to 100 kV only. So here this is very much important to consider its dielectric loss. This dielectric loss increases with increase in applied voltage. That's why this underground cable also we are maintain the operating voltage up to 100 kV only. Beyond that 100 kV, we are unable to maintain that much of high level of insulation. Applied voltage affects insulation resistance also. If V is increases, then what will happen? R decreases. According to Ohm's law also, just observe, V is directly proportional to I by R, or V is equal to I R, right? Here applied voltage also affects this insulation resistance. After that, age. Insulation resistance decreased with this increase in age. This is called aging effect. That's why our manufacturers are also giving instruction and warranty period for a particular materials. After that, this insulation materials slowly lose its mechanical strength and it gives some breakdowns also. That's why for a particular time period only it is working properly. After that, due to this aging, it loses its elasticity and its dielectric strength. all the properties will be changed after some period of time. It may be 5 years, 6 years, 10 years, like that. That's why age is also very much important factor. Classification of insulation material. This is the next thing. Up to now we are learned about properties and factors. What are the factors we are observed? Temperature, moisture, voltage and age. Temperature, insulation resistance is very much affected by temperature. It decreases, insulation resistance will be decreased with increase in temperature. In summer, the insulation resistance decreases due to rise in the temperature in atmosphere condition. Moisture is also. Moisture is very much high in the case of winter. The surface resistance and cause insulation breakdowns when the insulation material is exposed to atmosphere. After that, voltage. Insulation resistance decrease with increase in this applied voltage above a certain potential. Next, age also one of the factor. These are the properties and factors of insulation material. After that, classification of insulation material on the basis of operating voltage. In any electrical apparatus, the insulation can withstand a fixed temperature. The operating temperature affects the life of the insulation. The rating of an electrical apparatus is depend only on the temperature up to which the insulation can remain stable in its insulation properties. Different insulation material have different temperature limits. Hence, the insulation materials are classified into different classes on the basis of their operating voltage. So, the classification based on what? On the basis of operating temperature. This means what? Up to this temperature level, this insulation material properties are constant. After that, it will be changed. That's why the classification of material based on its operating temperature. It is classified as class Y, class A, class E, class B, class F, class H, class C. Let's see what is these classes. There are hundreds of insulating materials are available in market, right? We have to divide it as particular classes. See, this is a class Y. Its maximum working temperature is up to 90 degrees only. After that, if the temperature will increase, then all the insulating properties will be changed. That's why it is operated from 0 to 90 degrees. After that, it is not suitable more than that temperature. Cotton, silk, paper, wood, PVC, rubber, pressboard, like these type of materials are example for this class Y. See here, this is a wood. For example, wood is a very good insulating material, but after 90 degrees centigrade, then what will happen? The wood may burn. It becomes ash due to the high temperature. That's why it is not suitable for that. More than 90 degrees centigrade is not suitable for those type of application. Cotton also, it may be fired, right? That's why we have to consider its maximum working temperature. Here class 5 insulation material is, its working temperature is only 90 degrees centigrade. Example is wood, cotton, like that. After that, class A. This class A maximum working temperature is in 105 degrees centigrade. Cotton, silk, impregnated paper, paper immersed in a liquid, dielectric such as oils are example for this type of class A. Beyond this temperature, the oil may be burned beyond this temperature and it's fired. Here silk, cotton, all those things, and paper is also there. It may be fired and it may be burned and it turns into ash like that, more than that temperature. That's why up to 105 degrees centigrade only it is used. Class E insulation materials. Class E insulation material. This class E maximum working temperature is 120 degrees centigrade. Enamelled wire insulation on base of polyvinyl, formal, epoxy resins, moldings, power plastics are the example for this. After that, class B. Class B insulation material, its maximum working temperature is 130 degrees centigrade. 130 degrees centigrade. Mica, glass fiber, asbestos will be suitable bonding substances. Asbestos, where we are used in the previous chapter, we are used that asbestos at the bottom of the electric iron and kettle. Just remember that. Why we are used in that this case? Because of that, in kettle or electrical iron, its temperature is raised up to 130 degrees centigrade. That's why we have to maintain asbestos as a base substance for that, as a insulation material. There we are not used any silk or cotton or paper as insulation material. Okay? In kettle or electric iron we are used asbestos. So depend upon this application we have to select the material. Okay. After that, class F insulation material. Class F insulation material is 155 degrees centigrade. Mica, polyester, epoxide varnishes and other varnishes with a high heat resistances are the example for this. After that, class H. Its maximum working temperature is 180 degrees centigrade. Composite materials on mica, fiberglass, asbestos extra with suitable bonding substance such as appropriate silicone resistance are example for this. After the last thing is about the class C insulation material. It is above 180 degrees centigrade. Mica, porcelain, glass, quartz, ceramics, all are the. Here ceramic, where the ceramic material we are used, just remember. In fuse we are used that ceramic material, just remember. Just observe the nearby electrical appliance what you have. Observe its insulation materials. There are so many insulation materials we are used in our day-to-day life. Observe the surroundings what you have. Right? This fuse is having this type of material. Okay, these are the different types of insulation material. class Y, class A, class E, class B, class F, class H, class C. Let's see the first class, that is class Y insulation material. Class Y insulation material, if unimpregnated, fall in this category with operating temperature up to 90 degrees centigrade only. Paper, cardboard, cotton, PVC, all are the example of this category. Class A insulation material. Insulation of class Y when impregnated fall in class A with operating temperature of about 105 degrees centigrade. So the class E is examples are cotton, silk, impregnated paper, paper immersed in a liquid. Which type of liquid that paper is immersed? It is immersed in dielectrics such as oil. Transformer. In transformer windings, we are inserted this type of arrangement. A thick paper is used and is immersed in a liquid such as oil, like that. At that condition, we are used to prevent the short circuit in between the windings of low and high voltage windings in a transformer. We are used. After that, class E. Class E insulation material. Insulation of this class has operating temperature of 120 degrees centigrade. Insulation used for enameling of wires fall in this category mainly. PVCs. Enameled wire insulation on base of polyvinyl formol. Epoxy resins. Moldings, power plastics, like that, all are example for this class E insulation material. In our house wiring, we are used that cables of different colors, right? Red, blue, yellow, black, all those things are coming under this class E insulation category. After that, class B insulation. Impregnated material fall in class B insulation material category with maximum working temperature of about 130 degrees centigrade. Example for this materials are mica, glass fiber, asbestos. I just telling about this asbestos. Just remember, we are already studied this asbestos is used as the base material for our electrical kettle and iron box. In our previous chapter only we have learned about this. Okay. Because of that, and the kettle or iron box, its temperatures are raised up to 130 degrees centigrade. That's why we are not used any PVC type of bases or glass or cotton, like that. There we are used asbestos to prevent the leakages from the apparatus to the remaining surrounding. That's why we maintain its base with asbestos. Okay. After that, class F insulation material. Impregnated materials or glued with better varnishes to maintain its maximum working temperature up to 155 degrees centigrade. Mica, polyester, epoxide varnishes and other varnishes with a high heat resistance are coming under this category, class F. After that, class H insulation material. This insulation material either impregnated or not, operating the maximum temperature is or up to 180 degrees. Here, composite materials on mica, fiberglass, asbestos with suitable bonding substance such as appropriate silicone resins or silicone rubbers all are coming under this category, and these are the example for this class H type of insulation material. The last category is what? That is class C insulation material. Its maximum working temperature more than 180 degrees centigrade fall in class C. Here the examples are glass ceramic materials, polyterafluoroethane, quartz, mica, porcelain. These are the example for this class C. Right? So these are the classification on the basis of this operating temperature. Right. So these are hundreds of insulation materials are available in the market. That's why the insulation material can be broadly classified into three categories mainly. There are solid insulating material, liquid insulating material, and gaseous insulating material. The solid insulation material fibrous material. Fibrous means wood, cardboard, cotton, silk, asbestos, paper, like that. Integrated fibrous material. Plastic materials means PVC, rubber material, mineral water, ceramic materials, glass materials. Non-resinous material, all are coming under this solid insulation material. After that, liquid insulation material. Mineral oils means kerosene, alcohols, lubricating oils, waxes, all are coming under mineral oils. Here, what is the application for this? Just remember, in transformer, to cooling and to maintain insulation, mineral oil is only used in the transformers. So mineral oil is best example for a transformer. After that, synthetic liquids, vegetable oils. Vegetable oils means obtained from seeds of cotton, sunflower, soybean, pulp, etc. Sometimes these vegetable oils are also used as insulation material. After that, fluorinated liquids. Fluorinated liquids means similar to synthetic liquids but have very excellent cooling properties. That's why it is used as insulation properties and to maintain cooling for the particular machine also. And the next one is silicone fluids, Vaseline, varnish, all are coming under the liquid insulation materials. Mineral oils, synthetic liquids, vegetable oils, fluorinated liquids, silicone fluids, Vaseline, and varnish. And the last one is gaseous insulating material. Air, nitrogen, hydrogen, inert gases, neon, argon, mercury vapor, sodium vapor. Just remember where the inert gases we are used. We are used in that metallic filament lab in your previous chapter itself. There the lamp is filled with inert gases like argon. That lamp is completely filled. Right? Okay. Halogen, sulfur hexafluoride. Sulfur hexafluoride means SF6. Sulfur hexafluoride is very good insulating properties. instead of using normal substations, sometimes we are using sulfa hexafluoride, that is called gaseous substation. In that, this SF6 is used as insulation material and at the same time cooling purpose also. Carbon dioxide. These all are insulation materials, right? So our insulation materials are categorized as solid, liquid type of insulation material and gaseous type of insulation material. We have to study it in detail. Then we will understand for which property, for which application it is used, right? So in our insulation materials topic, we are studied the various properties of insulation material, that is electrical properties, chemical properties and mechanical properties. After that, the factor which are affecting this insulation materials, that is temperature, moisture, applied voltage, aging, like that. After that, we are move into classification of insulation material according to its temperature. It is classified as class Y, class A, E, B, F, H, C, like that. After that, the general classification is solid insulation material, liquid insulation material and gaseous insulation material. Thank you and thank you for watching this. We will continue the remaining in the next video class.